Hello students, welcome back to our class. Today we are going to discuss 7th chapter of our CBSE curriculum of grade 10, that is coordinate geometry. So the topic that we are going to discuss here now is coordinate geometry. So what is this coordinate geometry is all about? Even in grade 8 in the form of linear equations and in grade 9 in the form of coordinate geometry as well as a pair of linear equations, we will discuss something about this coordinate geometry. So this geometry deals with coordinate axis, it is nothing new. So this is the new version or the analytical form of plane geometry. See, here we deal with the coordinates. So that is why this geometry is said to be coordinate geometry or Cartesian geometry also, right. See, in this grade 10, what are we going to learn all about? We have three concepts in our grade 10 CBSE curriculum. That is, the very first thing is distance formula, how to find out the distance between 2 points, and the second one is section formula, and the third one is area of the triangle. So in this module we are going to discuss about distance formula. What do you mean by the distance, right? So distance formula about the coordinate geometry. See, if you consider a coordinate plane, for example this is y axis as well as this is x axis, you are given 2 points in the plane. Those 2 points are for suppose one point is like this point is 1, 2 and another point is given, this point is like 3, 5. These two are 2 points. See, if you are given those 2 points on the paper, easily you can figure out what is the distance between those 2 points just by measuring the scale. But here these 2 points are with coordinates. So here 1, 2 are abscissa and ordinate of the first point and 3, 5 are abscissa and ordinate of the second point. What are you going to find here? You are going to find out the distance between these 2 points A and B. So how is that possible? Is it possible by using the scale to measure? See, when you use the scale, then it may not be same as our actual distance. You know why? This 1, 2, 3, 5 are the positions of 2 points. The positions of the points depends on the scale taking on x axis as well as taking on y axis. And sometimes you cannot measure the exact length between 2 points by using our scale. You know why? Because our scale gives measurement up to 1 millimeter. Suppose if there is a length which is less than 1 millimeter, it is not possible to measure by using scale, because the least count of our scale, regular use of scale is 1 millimeter or 0.1 centimeter. So that if there is any measurement, any length which is less than that, we cannot measure with the help of the scale. So then definitely we need a specific method to obtain the distance between 2 points given in coordinate plane. So for suppose 1, 2 and 3, 5 are 2 points. I am going to find out the distance between these 2 points. I understood one thing, that I cannot measure the distance by using scale accurately, and moreover I do not know whether my calculation there is right or wrong, because that completely depends on how I am taking the values on x axis as well as on y axis. So that is why I need one explicit formula to find out the distance between 2 points. So for that I will take coordinate plane, okay. So and I am going to take 2 points on the coordinate plane. The very first thing that we are going to discuss in our grade 10 coordinate geometry is distance formula, okay. So distance formula. So what is this distance formula and what is it all about, okay. Let me take coordinate plane. This is x axis and y axis, and this is origin, and taking 2 points. For example, this is the first point A. Generally we take points in the coordinate plane as like x1 comma y1, and the second point, for example, this is B, is x2 comma y2. So these two are 2 points in the coordinate plane. Now I am going to find out the distance between these 2 points. This is what my primary task is. What is that value of D? Means distance between 2 points A and B. For that, I will just try to understand what do you mean by that point A x1 comma y1 and B x2 comma y2. So this is the position of the point A x1 comma y1 means what? The horizontal distance of the point is x1 and the vertical distance is equal to y1. That is why that point is named as x1 comma y1. I will try to utilize that information in order to find the distance between A and B. For that, the distance of this point from x axis, that is the vertical distance. Since this is y1, so vertical distance is y1, and what is the horizontal distance? Horizontal distance is x1. That is why that point is x1 comma y1. This is perpendicular. Let this point be some P, and again I will drop one perpendicular from B to identify what is the vertical distance of the point. Let it be some Q. Okay. So this BQ is about y2, and what is the horizontal distance? The horizontal distance is going to be x2. That is why that point is x2 comma y2. See, once observe here, this total distance OQ is equal to x2 and OP is equal to x1. Then what is the distance between P and Q? You can easily understand that the total distance is x2 and distance is x1. The remaining is the remaining part of this OQ, that is x2 minus x1. Hope you understand this. And then see, this is also perpendicular, you know that. From here I drop one perpendicular onto this vertical line. Okay, let this vertical line is, for example, AR is the vertical line drawn on BQ. Once you observe here, what is this quadrilateral APQR? Every single angle of the quadrilateral is right angle. So obviously you can say that it is a rectangle. We cannot say that it is a square because we do not know about the lengths of the sides, right? So since it is a rectangle, AR is equal to PQ. Since it is x2 minus x1, this one also x2 minus x1. And see, AP is equal to y1, so that RQ is also is equal to y1. If this is y1, this entirely it is y2. What about this only distance BR? This is y2 minus y1, right? Once you observe, there is a triangle formed. What is the triangle formed? ARB triangle or ABR triangle formed. So that from the adjacent figure, ABR triangle ABR is right angled, and right angle at R, and angle ARB is equal to 90 degrees. If ARB is equal to 90 degrees, then is there any familiar interesting concept defined on right angled triangle along with the sides? Yes, that is Pythagoras theorem. So that by Pythagorean theorem, hypotenuse square is equal to side square plus side square. Hypotenuse is what? AB, right? So hypotenuse square is equal to side square plus side square. They are AR square plus BR square. Therefore AR is equal to x2 minus x1. So that x2 minus x1 whole square plus BR is equal to y2 minus y1 whole square. So x2 minus x1 whole square plus y2 minus 1 whole square is equal to AB square. But we want distance between A and B only, right? Therefore AB is equal to plus or minus square root. Since the distance is positive, otherwise 0, that's why it cannot be negative. Therefore we cannot consider negative sign over here. Therefore AB is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. This is what is the formula for distance between 2 points x1 y1 and x2 y2. So this way we can derive the formula for distance between 2 points. And here you need to understand one thing, that whenever you are given 2 points to find out the distance between those two, then you will have to compare the first point with x1 comma y1 and second point with x2 comma y2, or second point with x1 comma y1, first point with x2 comma y2, that is your wish. And then see, for example, if I am going to find out the distance between 2 points a 1 comma 3 and b negative 2 comma 5, these two are 2 points. Just to avoid confusions, consider the first point as x1 comma y1. So, this is x1 and this is y1. Second point is x2 y2, and now substitute x1 y1 and x2 y2 in the formula for distance between 2 points. So, that is going to be AB is equal to square root x2 minus x1 whole square. What is x2 here? x2 is equal to minus 2 minus x1 is equal to 1 whole square plus y2 minus y1, y2 is equal to 5 minus y1 is equal to 3 whole square, right. So, when you simplify this, then you get square root minus 2 minus 1 equal to minus 3 whole square is equal to 9 plus 5 minus 3 is equal to 2, 2 square is equal to 4. So, 9 plus 4 is equal to 13. So, root over 13 units, you will have to mention units. So, this way you can easily figure out the distance between 2 points, any 2 points, by using the formula root over x2 minus x1 whole square plus y2 minus y1 whole square. But I have one idea to use this formula. Can we use this formula root over x2 minus x1 whole square plus y2 minus y1 whole square as x1 minus x2 whole square plus y1 minus y2 whole square? Is this okay if I use the formula in this way, right? See, both of them, let us try to, anyway the points are there, I am going to figure out what is the distance if I use this formula. I know whether the difference is there or not, but I just want to show you there is no difference between both of them. Why there is no difference between both of them, you will get to understand now, which is equal to square root x1 minus x2, x1 is equal to 1, x2 equal to minus 2. So, x1 minus x2 is 1 minus of minus 2 whole square plus y1 minus y2 3 minus 5, 3 minus 5 whole square. So, when you simplify this, what do you get? Square root 1 minus of minus 2 is equal to plus 2, 1 plus 2 equal to 3, 3 square is equal to 9 plus 3 minus 5 equal to minus 2 whole square is equal to 4. What is 9 plus 4? Is going to be root over 13. Is there any difference between both of them? There is no difference. It means there is no difference between these two formulas, but still there is something that you are not accepting, whether x2 minus x1 whole square and x1 minus x2 whole square both are same or not. Absolutely same. You know why? The value of x2 minus x1 may be positive, then its square, of course it is positive. If the value of x2 minus x1 is negative, then square of the negative number again it is positive. So, square of a negative number or positive number remains unchanged. That is why x2 minus x1 whole square and x1 minus x2 whole square both are same. But remember one thing in your mind, that x1 minus x2 is always not equal to x2 minus x1, but x1 minus x2 whole square is always equal to x2 minus x1 whole square. Okay. So, this is one simple logic that you need to remember, and this is the way of finding the distance between 2 points x1 y1 and x2 y2. Hope you understand, right? And we can use this distance formula in many ways, just to calculate some in some different ways and in some different applications. You would say that you are given, these are all applications of distance formula. Applications of distance formula. For example, you are given 2 points. Those 2 points are, one point is like 2 comma minus 5 and second point is minus 3 comma 2. These 2 points are equidistant from a point lying on x axis. Suppose this is a point on x axis. Find out a point on x axis equidistant from 2 comma minus 5 and minus 3 comma 2, then find out that point. Hope you understand what is the problem that I am going to give you. That is, find out a point on x axis equidistant from 2 comma minus 5 and minus 3 comma 2. So, how do you figure out the value of or the coordinates of the point P? Since this is the point P lying on x axis, then obviously any point on x axis whose y coordinate is equal to 0. We do not know what is the x coordinate. Let the x coordinate is some x, and this point, for example, this point is A and this point is B. Since according to the given problem P is equidistant from both A and B, it means distance between P and B is same as distance between P and A. So, what do you mean by that? Find out the distance between P and A and find out the distance between P and B and equate both of them. So, why are you going to equate them? Because that point, our required point on x axis equidistant from both the points A and B. So, that is why you will have to equate PA and PB, and you will get PA and PB means square root the distance between P and A and square root distance between P and B. To remove the square roots, you will have to square them on both the sides, and then you will have to solve for x. So, therefore, you will get the point on x axis. Hope you understand. So, this is what the very important concept, which is a very important application of distance formula, right. Find out a point on x axis equidistant from 2 points like 2 comma minus 5 and minus 3 comma 2. Like that, you will be given one more point, one more problem like find a point on y axis, anywhere on y axis. See, I have taken P on positive y axis. Why it is not on negative x axis? You can take anywhere, just for reference I am taking there. You understand? I am taking one more point. Again next problem is given that find out a point equidistant from 2 points, a point on y axis equidistant from 2 points. For example, first point is 3 comma 5 and the second point is minus 2 comma minus 3. So, if you want to find out the point on y axis, what is the general form of a point on y axis? Generally, any point on y axis whose x coordinate is 0, we do not know what is y. That is what is our primary task, to find out the value of y. So, join both of them and join these two. According to the problem, this distance and this distance both are equal. So, you will have to equate both the distances after applying the formula for distance between 2 points. So, this way you can use distance formula in order to find out a point on x axis or find out a point on y axis, okay, equidistant from the given 2 points, right. And one more thing is, like you will be given 3 points, okay. So, 3 points are given. First point is x1 comma y1, A x1 comma y1, and second point is B x2 comma y2 and C x3 comma y3. So, these 3 points are given. What are you asked? You will have to prove that these 3 points are the vertices of equilateral triangle. These 3 points are the vertices of equilateral triangle. So, how do you prove that these 3 points are the vertices of equilateral triangle? By using our distance formula, because according to the properties of equilateral triangle, all the 3 sides are equal as well as all the 3 angles also equal. But whatever so far learned in our coordinate geometry, we learnt what is the formula for distance between 2 points. We know how to figure out the distance between 2 points. So, is it possible to verify whether those 3 points are equilateral triangle vertices or not? Yes, we have the property of equilateral triangle that all the 3 sides are equal. All the 3 sides are equal means what? Lengths of 3 sides are equal, means length of AB is same as BC is same as AC. Length of AB means what? That is the distance between 2 points A and B. So, find out the distance between 2 points A and B and distance between 2 points B and C, distance between C and A. If all the 3 are equal, then they are the vertices of equilateral triangle. Suppose if you are asked to prove that it is isosceles triangle, so how can you prove that the triangle is isosceles? It is very easy to prove as per the properties of isosceles triangle. In isosceles triangle, 2 sides must be equal. So, those 2 sides must be equal means what? You find out the distance between AB and BC, they may be equal, or BC and AC they may be equal, or AB and AC they may be equal. Okay. So, if any one of the condition is holds good, then we can say that the triangle is isosceles triangle. For example, if you want to prove that the triangle is right angled triangle. So, right angled triangle means what? What do you mean by right angled triangle? Definitely you will have to check whether they are the sides of right angled triangle or not by using Pythagoras theorem. So, in order to verify Pythagoras theorem, definitely one of the sides must be greatest, right. So, if AB is greatest side, then AB square must be equal to AC square plus BC square. Otherwise, for example, AC is greatest side, then AC square is equal to AB square plus BC square. Otherwise, BC may be greatest side, so BC square is equal to AB square plus AC square. So, it can be true, or it can be true, or third one can be true. Then we can say that the triangle is right angled triangle. Suppose if you want to prove that the triangle is right angled isosceles triangle, right isosceles. So, right isosceles triangle means what? It should be right angle triangle as well as it should be isosceles triangle. It means definitely one of these conditions must be satisfied and one of these conditions also must be satisfied. So, hope you understand. So, that any one of the pair of sides must be equal and then Pythagoras theorem must be satisfied. Then we can say that they are the vertices of right angled triangle. This is about the vertices when they are the vertices of triangle. Okay. For example, if you are given 4 vertices and you are asked to verify whether those 4 vertices are the vertices of, see, for example, this is a quadrilateral A x1 comma y1, right, and B x2 comma y2 and C x3 comma y3, D x4 comma y4. Okay. So, you are going to prove or verify whether they are the vertices of parallelogram or not. Vertices of parallelogram or not. When the what are the properties of parallelogram as per the sides? See, AB, BC, CD, DA are said to be the sides of the parallelogram, then definitely opposite sides must be equal. Opposite sides means what? AB must be equal to CD and AD must be equal to BC. Then we can say that the quadrilateral is a parallelogram. Since parallelogram is a very basic fundamental quadrilateral, that is why you just need to prove that AB is equal to CD and AD is equal to BC if you are asked to verify whether they are the vertices of parallelogram or not. So, nothing else is required in order to prove that is a parallelogram or not. Hope you understand. Coming to the second one. So, how can you prove that they are the vertices of rectangle? Now, again, what are the properties of rectangle? And according to the definition of a rectangle, if one angle of a parallelogram is right angle, then it is said to be rectangle. Hope you understand. If one angle of a parallelogram is right angle, then it is said to be rectangle. So, here in order to prove that they are the vertices of rectangle, definitely you will have to prove that opposite sides are equal, AB and CD are equal, AD and BC also equal. Then you cannot stop. In addition to this, because if you just prove AB equal to CD, AD equal to BC, it can be parallelogram also, right? Then how can you say that it is rectangle? Then definitely you will have to figure out the distances of the lengths of diagonals. So, if the diagonals also equal, then we can say that the quadrilateral is a rectangle. If diagonals are not equal, only opposite sides are equal, then it is a parallelogram only. You understand? But for parallelogram, you do not have to find out the diagonal lengths, because if opposite sides are equal, automatically it is a parallelogram, right. And coming to third one, when you can call it as a rhombus. See, according to the properties of rhombus, ABCD is a rhombus when all the 4 sides are equal and diagonals are not equal. Okay. all the four sides are equal means what? AB is equal to BC is equal to CD is equal to DA, and for rhombus you don't have to find out the diagonals, because if all the four sides are equal then it is said to be rhombus. You understand? And coming to next one, what is that? That is square. So when a quadrilateral is said to be a square, and you will have to distinguish between rhombus as well as a square, because in square all the four sides are equal as well as both the diagonals are equal. So that is the additional property of square from rhombus. So that is why you will have to prove that AB is equal to BC is equal to CD is equal to DA, and diagonals AC and BD also equal, then only you can say that it is a square, otherwise it is not a square. So these are all different applications of our distance formula. So hope you understand. This is really interesting. Thank you.